Okay, so here are some examples of having to complete the square. Completing the square gets us the fastest to vertex form. And vertex form is y equals a x minus h squared plus k, where h comma k is the coordinates of your vertex, which is the highest, which is a maximum if it opens down, or if it opens up, the minimum of a parabola. So right here, we're going to be asked to complete the square in this quadratic function. What we're going to do is make sure that the a term only has a coefficient of 1. So if there is not a coefficient 1, we're going to factor out that as a common factor between the a term and the b term. We're going to leave out the c term because we're basically going to force a trinomial perfect square. So right here, you already have an a term with a coefficient of 1, so we don't have to factor out anything between a and b. We're just going to bracket off the a and the b term and leave out the c term. No one likes the c term. It's not friends with it. So then what happens is you're going to force a trinomial perfect square. What we're going to do is just take the b term, divide by 2, and square it. So 8 divided by 2 is 4, and squared, because 4 times 4 is 16. So you're going to add 16 and minus 16. The reason we're going to add and subtract 16 is because when you add and subtract something, you really haven't changed the value of this equation. Meanwhile, plus 7 is just still hanging out there because nobody wants to be friends with it. So then what's going to happen is that you're going to take this negative 16 out of the bracket. Now, you have to respect whatever number's in front of this bracket here. In this case, it's 1. So really, negative 16 times 1 is still negative 16, so there's not a lot of change there. So what I'm going to have here is negative 16 plus 7. So my final answer is x plus 4 squared minus 9. How to get to the x plus 4? This, again, we force a trinomial perfect square because the square root of this, which is x, times the square root of this, which is 4, which is 4x, times 2 gives me the magnitude of the b term in the equation right here. So what happens is that this is a trinomial perfect square. You just need the square of the first term, the square of the last term, and the sign in the middle. All of that squared is your answer. So this right here is easy because now you also know the vertex. The vertex for this quadratic would be negative 4, comma negative 9. Remember, it's x minus h squared. So it's the opposite, right? So it's minus 4, meaning that the coordinates for the vertex in this case is minus 4, comma minus 9. Now this is a little bit harder of an example because your a term is not 1. You have 3x squared minus 12x minus 5. So what we're going to first do is factor out 3. You get x squared minus 4x. We're going to leave out the c term minus 5. Notice that I factored out a 3 out of here to get negative 4. Now, the question is, what if this makes a fraction? If it makes a fraction, that is possible as well, but you have to be wary about it. Now, what happens now here is that we're going to make, again, a perfect square. So what we're going to have is divide this b term by 2 and square it. So 4 divided by 2 is 2. That squared is 4. So we're going to add 4 and subtract 4 so we don't change the value of the equation. Now, this time when you take out negative 4 from the bracket, you have to respect that 3 that's in front. So you have to do 3 times negative 4 to give you negative 12. Okay? So then you're going to factor this trinomial perfect square. You get the square of this term, the square of this term, and then you square the whole thing. So it goes 3 times x minus 2 squared minus 17, because minus 12 subtract 5 is negative 17. So again, this is trinomial perfect square because the square of the first term, which is x, times square of the last term, which is 2. Multiply those two together is 2x times 2 is 4. Do I care that it's negative 4? No. As long as it hits the magnitude of the b term or the number value of the b term, I'm fine. So we force a trinomial perfect square, so now we actually know the vertex for this one to be 2, comma, negative 17. So that would be the vertex because it's x minus h squared plus k.